All right, today we are diving deep and decoding the absolute core of pretty much every device you own, the kernel. It's that invisible engine that's powering literally everything you do. So let's get right into it and see how it all works. I mean, have you ever really stopped to think about that? You hit the power button, there's this brief moment of darkness, and then boom, your entire digital world just appears. What kind of magic is happening in that split second? Well, the answer to that question, and really the hero of our story today, is the kernel. Here's a good way to think about it. If your operating system is a giant, bustling city, the kernel is all the invisible stuff that makes it run. It's the foundation, it's the power grid, it's the plumbing, it's the entire infrastructure that everything else is built right on top of. Okay, so we have this big picture idea of the kernel as the city's infrastructure. Now let's zoom in a little bit and get a bit more specific about what this core really is and what it does. Whoa, okay, that's a mouthful, right? Let's just break that down real quick. Monolithic just means it's one big program, but modular means you can plug new pieces in, like drivers for new hardware. But the most important word on this whole slide is intermediary. The kernel is the ultimate translator. It lets your web browser talk to your Wi-Fi card without either of them needing to know the messy, complicated details of how the other one works. And this diagram? This is a perfect picture of that structure. Let's think of this as our master map for this whole explainer. See, way down at the bottom, you've got the physical hardware. And way up at the top, you've got your apps. The kernel is everything in between, all these layers, from the low-level stuff that talks directly to the hardware, all the way up to the core systems that manage everything. We're going to keep coming back to this map. So if that was the high-level conceptual map, let's get our hands a little dirty. Let's go look at the actual blueprints, the source code that developers actually use to build the kernel itself. So this is the kernel's source tree. And I know it might look a little complex, but it's actually incredibly logical. Each one of these folders has a different job. One handles memory, another one handles your files, another one handles the entire network. It's like a perfectly organized library. But one of these folders is way, way bigger than all the others. And this is the part that might just blow your mind. About 60%, yes, 60, of the entire Linux kernel source code, we're talking millions and millions of lines of code, lives inside just one of those directories, the driver's directory. So what does that tell you? The most important takeaway is this. More than half of the kernel's entire being is dedicated to just one thing, being that translator for every single piece of hardware you can imagine. Every graphics card, every keyboard, every Wi-Fi chip, they all need their own driver. That one number just proves what the kernel's real priority is. Now, to make this all a bit more concrete, let's focus on a specific type of hardware. We're going to zoom in on the ARM architecture, the powerhouse chip that's inside devices like the Raspberry Pi and, well, most of the smartphones in all of our pockets. So inside that Arch directory we saw a minute ago, the code is split up. You've got a folder for the older 32-bit ARM systems, think of the original Raspberry Pi, and then you have a totally separate one, ARM64, for all the modern 64-bit chips that power a Raspberry Pi 5 or a brand new smartphone. This architecture-specific code, it handles the really, really low-level tasks. You can think of it like a super custom instruction manual just for your specific chip. It tells the kernel exactly how to manage power to save your battery, how to juggle tasks across multiple processor cores, all the nitty-gritty details. It's the custom tailoring that makes a general-purpose kernel fit your specific device like a glove. Okay, so we've seen the map, and we've looked at the blueprints. Now for the really cool part. Let's watch it all come to life. This is the liftoff sequence, the incredible journey from the moment you hit that power button to the second you see a login prompt. It's like a perfectly choreographed relay race. First, power hits the chip, and this tiny built-in program called a bootloader wakes up. Its only job is to kickstart a second, more powerful bootloader. That one finds the Linux kernel on your storage drive, loads it into memory, and then, poof, it hands over complete control. From that exact moment on, the kernel is in charge, initializing itself and finally starting up the part of the OS that you can actually see and use. And if we go back to our master map one more time, you can see exactly what's happening. The boot process is literally a climb up this stack. It starts at the very bottom with the bare metal hardware and just systematically builds up each layer one by one until it's ready to run your applications right at the very top. So why does any of this matter? Why is having this mental blueprint in your head so important? Well, it's because understanding this structure, it's the key to understanding how your devices work at the most fundamental level possible. So let's just recap the big takeaways, right? First, the kernel is that absolutely essential bridge between software and hardware. Second, its source code isn't some chaotic mess. It's a beautifully organized library. And third, that boot process isn't magic. It's a logical, layered, step-by-step climb. Having this map in your head is your starting point for exploring anything deeper. So, we've laid out the foundation. We've basically handed you the blueprint to the very core of modern computing. The only question left is, now that you have the map, what part of this amazing city are you gonna go explore next?